Welcome to Conceptual Cambridge. This is the last topic of AS level pure mathematics. So today we are going to go over integration and you can see what we are going to cover. It's listed over there. So let's get right into it. So firstly, let's answer what is integration. So basically it is generally defined as the reverse process of differentiation. And if you don't know what differentiation is, you should first watch my other video on this channel. I will link it on the top right. Alright, so if you have watched that video, then you know we use differentiation for finding gradient of a curve from our equation of a curve. Similarly, we are going to use integration for finding the equation of a curve from the gradient of a curve. So firstly, let me show you what I mean by that. So let's take an example. Alright, so the example I'm going to use here, let's say we have an equation of the curve y is equal to x squared. And now we know the differentiated form of this is supposed to be dy over dx is equal to 2x. And by definition, we know that integration is supposed to reverse the differentiated form back into its original form. So 2x is going to be converted back into x squared. And how is this done basically? If you come over to the right side of the page, you will see that we have been given something like there is a function over here and then there is an integrated form over here. Basically, this is just the general formula for integration, and this sign is going to tell you when you have to integrate. So let's come over to our question. Let's say we have to integrate 2x. Firstly, we are going to write it like this: 2x dx, as we are going backwards. So this is how you're going to write it, and then you know that 2 is just a constant, so it can be moved outside, it doesn't matter. So it can be equal to 2 and then like this. So you only have to integrate the x and then you can multiply it by 2. So now let's do that. Let's apply it into the formula. So basically it's going to be something like this: x raised to the power of n plus 1. As you can see, the power was 1, so it's going to become 2, 1 plus 1. And now we have to do the same thing below it. So x square over 2. And now as you can see, we can cut these out. So this is going to give us back our equation of the curve x square, as you can see from before. And one issue that people face with this is that they forget to put the constant of integration. They forget to put plus c. We're going to write it like this: x square plus c. As we don't know what c is, basically over here the c is 0. As you can see, we only have x square, so c is supposed to be 0 over here. Alright, so let's move on to an example question that might help explain it a bit more. So alright, here we have the question: a curve is such that dy over dx is equal to 6x raised to the power of 5 minus 18 over x cubed, and once 6 is a point on the curve, find the equation of the curve. As you can see, we have to find the equation of the curve, so this is going to be integration. So let me just start. Let me write down the question: dy over dx is equal to 6x5 minus 18 over x cubed. Firstly, I can separate it, or I can bring the x cube upwards. So 6x5 minus 18 into x raised to the power of minus 3. As it's going up, it's going to be negative. So let's multiply it inside: x5 and minus 3, so 6x square minus 18x minus 3. Alright, so you have this form and you're going to integrate this. So let's start with 6x square first. Let's put the 6 outside and let's integrate x square. Let's see, x 6 into x raised to the power of 2 plus 1, so x cube over 3. So this is going to be, and now you can just write it like this, 2x cube. Alright, now we can do the same thing for minus 18. Let me write it over here. Minus 18 integrate x minus 3 dx. So let's see, minus 18 into x minus 3 plus 1 minus 2, and minus 3 plus 1 minus 2 is going to come over here too. So the minus and minus are also going to cancel out. We get 9x minus 2. Alright, so the integrated form that we will get is going to be 2x cube plus 9 x minus 2. We can just take it down, does not matter, and then don't forget the plus c. This is going to be your integrated form, but they also gave you the information that 1 and 6 are points on the curve and you have to find the exact equation of the curve. So first of all, let me erase some of the upper things. Alright, so now we have our equation of the curve and we're going to use this. So it says that x is 1 and y is 6. We just have to input this back into the equation. 6 is equal to 2 into 1 cube plus 9 over 1 square plus c. So you can do it like this, 2, and this is just 1, so it does not matter. 2 plus 9, 11 plus c. So 6 minus 11, which is basically minus 5, is going to be c. So you can just put it in the other form, 2x cube plus 9 over x square minus 5. This is how you're going to solve these type of questions. Let's move on to another form of the integration. So this is another type of question you can get. We have to resolve these, but as you can see over here, this all is in brackets, so you can't just keep opening it to make it into a simpler form. So there is a general formula for all of this. So let's say you have ax plus b raised to the power of n. Alright, so the general formula for integrating this is going to be ax plus b raised to the power of n plus 1 over a into n plus 1. This is another general formula. This is not given and you have to memorize this. You have to use this in these type of questions. So let's try and apply it. Alright, so 2x minus 3 raised to the power of 4. If we apply it, we are going to get 2x minus 3 raised to the power of 4 plus 1. That gives me 5 over 2. Whatever is your coefficient of x, that is going to come out, and 2 into 5. So this is just 2x minus 3 raised to the power of 5 over 10. Don't forget the plus c. Yes. Alright. So the other question, we are going to solve that now. Alright, so first of all, you can just take this up. So it's going to become integration of 5 into square root 2x plus 7 dx. You can take the 5 outside as it is just a constant, and you can also convert this into the other form for solving it. Let me show you how. So 5 is outside and now you have to integrate 2x plus 7 raised to the power of, actually it's going to be minus 1 over 2 as it's coming up. Below it was 1 over 2. Alright, so now we have to solve this. Let's try solving it. So basically 5 into 2x plus 7, the minus 1 over 2 plus 1 is supposed to be 1 over 2, and now below 2 into minus 1 over 2 plus 1, so this is just going to be 1 I think, and now this is going to become 5 square root 2x plus 7 and plus c. Yes, this is going to be your answer to this question, and please ignore this part. This is supposed to be minus 1 over 2. Alright, let's move on. There's also another form for this question that they may ask you. Let's try that. Alright, so this is the other form of question they may ask you. So let's see over here. They have given you the differentiated form, as you can see, and we have to, first of all, we have to differentiate it. Alright, they're asking us for it. So let's see. Y is equal to 3x square minus 4 raised to the power of 8. Alright, so now there are two ways to solve this question. You can use the chain rule, or that differentiation of inside into the differentiation of outside, but let's use the chain rule, even though it's longer but it explains more. So let's say we take another variable like u, and we make it 3x square minus 4. Alright, so y is going to become u raised to the power of 8. So what we can do is, first of all, take the differentiation over here with respect to x. Du over dx is equal to 3 into 2, 6x. So this is the differentiated form of that, and now dy over du is equal to 8u7. And now what we can do is, now we can apply it. So you can see dy over dx is what we need, and we can use dy over du into du over dx. These are going to cut out. Alright, so now let's apply that. Dy over du is 8, and you know what u is. We can just convert it back into the original form. 3x square minus 4 raised to the power of 7, and this multiplied by 6x. The answer you will get is 6 into 8 is supposed to be 48, x into 3x square minus 4 into 7. Alright, so this is how you will complete the first part of this question. And now, as you can see, the second part is on integration of this. Alright, so let's see what we can do over here. You know that the integrated form of this is going to be 3x square minus 4 raised to the power of 8. This is going to be its integrated form. Let me write it. Integrated form. Alright, so for simplicity, what you can do is you can find a way to change this 6 to 48, so you can get to your answer more easily. So if you see, we can 48 divided by 8 gives us 6. Alright, so we are going to use this fact over here. You can use this for other types of question too, but let's see. Alright, so what you can do is basically 48 into 1 over 8 x into 3x square minus 4 raised to the power of 7 dx. This is what you are supposed to find, right? but you can see that there are two constants over here. So we can just take one of the constant outside for our own simplicity. So we are going to get 1 over 8 integrate 48x into 3x square minus 4 raised to the power of 7 dx. Alright, and now you know that the integrated form of this all is already given to us, so it's going to become 1 over 8 into 3x square minus 4 raised to the power of 8, plus c also. Alright, so this is the end of part 1 of this video, and next we are going to cover the area of a curve and the volume of a curve. Alright.